One of the hardest things about the FPV hobby is figuring out what the best control link is to use or video link. And you would think, oh, just do a range test and then you'll know the answer. But as someone who has tried to do range testing, getting it right is really difficult. And that's why I am excited today to be talking with Wezley Varty, or just Wez as you go by. You have gotten some notoriety for doing these range tests of control links and video links on your YouTube channel. But I have a feeling there's more to you than just a guy who flies long range. So I'm very happy to sit down with you. Wezley Varty, welcome to the channel.
Great. Thanks, Josh. Yeah, great to be here.
And I do want to talk about the range tests you've done, the methodology you use, and some of the results. But I actually would like to just hear a little bit more about, like, who is Wezley Varty? Like, I can tell from your accent, you live in Australia?
Gold Coast, Australia, which is where I'm doing all my range testing. In terms of my background, I've kind of always been into electronics and things like that as a kid. Loved taking things apart and probably not so much putting them back together again, much to my parents' dismay sometimes. Mm-hmm. So kind of naturally qualified as an engineer when I ended up finally going to university. Did mechatronic engineering, which is kind of process control with a bit of robotics and electronics mixed in. But ended up getting hired as a software developer at a software team here in Australia that we build the software that basically controls the road network, so things like traffic lights and things like that. We supply to government, and it's a fairly fulfilling job, but definitely keeps me busy. So in spare time, that's when I'm kind of doing my RC stuff, range testing, racing. Racing was kind of what got me into it all.
So you fly long distance wings, right? You like long distance. You also do FPV racing. Yep. And you do software development too. I believe you work on the Express LRS project, right?
Yeah, that's correct. When I say I work on it, I've got contributions, but I'm nowhere near as kind of big brain as some of the guys that have joined semi recently. There's some really active guys in there doing some fantastic stuff that completely goes over my head. I'm definitely involved. I got involved really early with that. So it was kind of, when I got involved, it was Jai and Alessandro, I think, flying it, and that was it. So when I came on board, there was 3 of us. And funnily enough, we never really aimed for range as like long range wasn't the goal with Express LRS. The initial goal, because it all kind of started with 900 megahertz, was basically just to provide a faster packet rate than Crossfire, which is what everyone was using for racing at the time. So that was kind of the aim, was to make it the fastest link. And by doing that and kind of having to shorten the packet size right down with Express LRS, it also, with the byproduct, was like we had amazing range as well. And it's kind of a bit of a shock when I started to push it out further and further, and it's got just won't fail safe. That was pretty interesting.
Yeah, it's such an interesting project because it started with this drive to develop this high performance, and with Crossfire sort of as the bar to beat, right? And that sort of compelled you guys to, but you didn't just stop with, Crossfire runs at 50 hertz and 150 hertz. Express
Yep.
LRS, it goes up to at least 500 hertz and maybe 1,000, right?
500 hertz with Edge TX build, and 1,000 is kind of, you've got to build your own handset to get 1,000 hertz. So it's not really something that most users would be using.
Right. And I think there certainly are some questions of whether, how much is the law of diminishing returns. But as you said, if you can build a protocol that can do like 250 hertz or 500 hertz packets, as soon as you start slowing it down, you get much, much better range. Just because when you're sending less data, you could basically trade data for range. So you sort of stumbled into this really, really long range control link, or a really high speed controller, or really both, because Express LRS goes like on 500 hertz. How far can you go?
I think we've had guys out to like the 5 or 6 kilometer mark, and that may have even been with the SMD antenna. So I actually haven't personally tested 500 hertz with a normal T antenna on the RX and actually pushed it and see how far it will go. It's a good question actually, because one of the things that I really try and focus on with my testing is keeping the packet rate the same between all of the links that I'm testing. So you see a lot of reviews or comparisons on YouTube and things like that, but they've got, Tracer at a fixed 250 hertz packet rate, but Express LRS was set to 500 hertz or something like that. Funnily enough, Express LRS still went further in that comparison, but it's not a direct apples to apples comparison then. So the important thing, the reason I haven't put any effort into testing 500 hertz is because Tracer is fixed to 250 hertz. And if you're trying to compare Tracer, Ghost, and Express LRS with the three main 2.4 gig links, then you want to try and keep as many of the parameters as you can the same between all of them to give the fairest comparison. So I've kind of been limited to 250 hertz because that's all Tracer supports.
Yeah, this is something I've kind of struggled with when doing experimental design, because there's one approach where you say, we're going to hold as many variables constant as possible, and we're going to reveal which sort of underlying technology has an inherent benefit. But there's another approach where you say, like, if you're testing two video transmitters against each other and one of them goes to 1 watt and one of them goes to 500 milliwatts, I mean, if you want to know which one's going to go further, you would do what a user would do, and you would set them both at max power. But especially when you get into things like this 500 hertz, output power, there are so many variables, it can be very hard to communicate accurate information to users or to just a lay person who goes, if you were to set Express LRS to 500 hertz, maybe it would get less range than Tracer, or it would certainly get less range than it would at 250. And people would walk away with incorrect conclusions, perhaps.
I guess the nice thing about testing RF devices is you can extrapolate based on the initial results that you get. So if you test on 20 dB, 100 milliwatts, you can find that range and then increase the dB power output by a set amount, go up to 30 dB, and you've got a 10 dB increase, and you can plug that into a calculator, which is just doing fancy math on the back end, and see exactly how far you should expect to get on an extra 10 dB of power. So testing on a consistent 100 milliwatts should allow you to extrapolate for any power output then. Like you said, it's a little bit different with packet rates rather than power, because that's more difficult to extrapolate for. But I definitely see your point. Like, you made a good point in, I think it was one of the DJI versus Sharkbite videos, where Sharkbite only goes to 500 milliwatts, but DJI goes to 1.2 watts. So,
and people said, well, that's not fair.
Yeah,
you should test DJI at 500 milliwatts. And I was like, listen, if you were going to drag race two cars and one of them had 600 horsepower and one had 400 horsepower, you wouldn't be like, oh, that's not fair, right?
Exactly.
One has more power. Everyone's going to use it. But I think what you're trying to do more is test the underlying performance of the technology. And that's why you hold the output power and the packet rate consistent, and you say, who wins. So let's talk some more about your experimental design, because, I mean, I've done some quote unquote range testing, and I always put big caveats on it, because anytime you have obstacles or terrain in the way, it's compromising your results. How do you test range?
So probably the most important thing is to find a good hotel stairwell. No, I'm kidding.
I did that.
Who does that?
Listen. Here's the thing. Ghost had just released. Everyone was very curious, and my only goal really was, people were saying 2.4 gigahertz cannot have penetration or range. They were saying that, and I was like, you are wrong. You don't understand the magic of LoRa. And so I was like, but I was on a trip, and I was like, what can I do? I have to make a video. Yep. I tried to put all the disclaimers on it that I could, that it was not a true range test. But I mean, it did go pretty far.
Definitely. Yep.
Yeah.
No, just playing. So in terms of what I find important, obviously, like I said, consistency is important. So one of the things that I try to do is fly a consistent flight path. And again, coming back to other reviews on YouTube and things like that you see, there might be 3 different people that have tested 3 different links, Express LRS, Tracer, Ghost, but in different environments and, potentially on different settings as well. But that aside, even just the RF environment will affect how far you'll go. And that's even more important with Tracer because that seems to be the one that's really affected by RF noise. And there's a known spot along the flight path that I tested, and I think I mentioned it in one of my Ghost testing videos, where there seems to be RF pollution around that area. I think there might be like a microwave link or something like that around there. And that seems to knock Tracer out of the air on any power setting except for ludicrous. So something like that, yes, that shows... it compromises the range, the max range that you'd potentially get with Tracer if you were testing in the Swiss Alps, which is where Trappy claims he gets his 25 kilometers from. But we can't test, I can't test Ghost and Express LRS in the Swiss Alps as well and compare what result they would get with a completely no noise floor RF environment. So the important thing with my testing is you're flying the same power and settings along the same flight path, and they're all going to experience that RF noise at that same point. And some of them are going to push past it, and some of them aren't. And I think that's kind of more representative of where most people will be flying. We're not all flying in the Swiss Alps. Some people flying in the city where there's plenty of RF pollution. So having something consistent is important. I think the other thing that I like to do with my testing is to kind of show the out-of-the-box performance that you get. So I don't want to use a 5 dB Moxon or something like that on one. I try and use the same out-of-the-box dipole, the same T antennas, everything like that they came with. So it gives people an idea if I buy this, take it out of the box, install it all and fly it, what kind of range could I expect? So I think that's important as well. And it kind of keeps the playing field a bit fairer. And I think probably the last thing that's important is make it entertaining. Like, honestly, it's great to have a scientific approach about it, but at some point it just gets a bit dry. You push too far with just all of the scientific, slide after slide, talking about the scientific side of it. You've got to kind of have, the crashes and the juicy B-roll and stuff like that in there to keep it entertaining.
Yeah. You did have a crash recently. So you fly, I'm not sure if people already know this, but you fly a wing and you basically take off with the wing on sort of a hillside and you fly out and back in a line. What's the range? You had a wing that you lost. What was the range on that one?
Yeah, that's actually a funny point. You say I fly a fixed wing, but kind of when I first started long range testing Express LRS, I started with an 8-inch quad. And so I was getting out to 5 or 6 kilometers and things like that. And obviously the limitation there was battery. So at that point, I kind of said, screw it, I'll just buy a fixed wing and they go far, chuck in a big battery and we'll see how far we can push this thing. And I'd never flown fixed wing at all up until that point, or any kind of airplane or anything. It was
so right into long range, right into long range. And
it was a huge learning curve with CG. I'd never dealt with CG before, with a fixed wing and, launching and everything like that. So there was plenty of crashes and learning how iNav worked. I think at one point the wing was probably more hot glue than foam. Yeah, when you say I fly a fixed wing, it was more just a tool to get the job done, to push it out and see how far it would go. I did have one originally. I had a AR 900. That was the one that I lost with Ghost. Just wasn't expecting it to go as far as it did, really. So it was a pleasant surprise on Ghost's behalf.
Right. The range test result was good, but then the plane ran out of battery and didn't make it home. To be clear, it didn't fail safe, right? You just ran out of battery.
No, Ghost did fail safe. So basically, the way I try to do it is just push it until it fail safes, and then iNav returns to home and come back.
I mean, the crash was not because of a fail safe.
Yeah, that's right. Yeah, 100%. Yeah, that was.
You dumped it in a lake.
Well, that one was the DJI one.
You've lost 2 since I knew you. Oh gosh. Yeah. I mean, they say if you fly long range, you're going to lose it. But I feel like if it was returned to home and the battery died, I feel like that's at least 50% pilot error.
I'd say it's probably 100%.
All right, I was trying to be generous.
Yeah. Yeah. No, that was just poor planning on my part.
Well, and I mean, you had a wing that went like 30 kilometers or something, and that's not enough. Even reducing the output power of some of these protocols, they just have so much range that you couldn't get them to fail safe. And currently, what's the range of what are you currently flying, and what kind of range does it have?
So AR Pro is what I'm currently flying. I'm getting out to about 40 kilometers, and that's probably about as far as I can push it. People keep saying, if you cram more battery in, and you could do this here, and etc. But the other limit that I've got is my 5.8 gig video link.
Wow. You're not flying like 1.3 or something?
Well, I found that one out the hard way. So when I was first doing my tracer testing, I was flying tracer on 1.3, and I was getting terrible range. And I contacted Trappy, and he said, "Hey, are you using 1.3 video with that? 2.4 and 1.3 don't play nice." And yeah, so I learnt that one the hard way. And so yeah, you can't use 1.3 with a 2.4 gig link. So you've got to use 5.8. So 40Ks is about the limit at the moment for both video and battery, but I do have another big plane that I'm building at the moment. It's kind of over here off camera somewhere. But that one, I've got some interesting ideas about how to try and push the 5.8 gig video a bit further than what I'm getting. So I've got a VTX with a ton more power. I'm using the 3-watt AKK VTX on this one. But the other thing I'm doing is I've got a directional antenna. So I've got a helical antenna on the wing, on the plane.
Wow.
And I've actually put it on a servo so that it faces backwards as I'm flying out. And then when I turn around, it flips around forwards, and then you're beaming 3 watts of...
I mean, a lot of people will put a high gain antenna on the ground station, but correct. I mean, with the plane sort of moving and stuff, the potential for losing that if it pitches up or pitches down seems pretty high. I guess you're going to see it. That's going to be plane number 3 that you lose.
I hope not, because this one's expensive.
I mean, it can fly home. It's got iNav. It's autonomous. Yeah. If you completely, because when you say you get out to 40 kilometers with 5 gigahertz, I think that's still pretty impressive, and I think people would be interested in knowing how you do that. But the video that you're seeing at 40 kilometers, most people wouldn't consider to be flyable if they were like doing like typical FPV freestyle-y stuff.
Definitely, yeah. It's just a colored, staticky mess out at 40 kilometers. I have to have a run cam onboard DVR onboard the wing so that I can still get the range results. You can still see the OSD in post, because otherwise you just wouldn't be able to read it. So having returned to home with iNav and just being able to hit that button and have it come back is essential.
Yeah. You ever had a video drop out and you hit return to home and then you're just like waiting for the video to come back and hoping?
Well, I mean, that's actually kind of what happened with the DJI testing, because I don't know if you know, but when you get to that range limit with DJI, it just drops to a black DJI screen. And I did have onboard video recording on the wing, so I had the analog feed so I could get the distance and everything like that. But, I just put that up, fly out, and wait for it to black screen, and then you'd be blind for 30 seconds until the video came back, kind of hoping that it was going to come back. When the spaceship goes behind the planet and Houston has to wait for the signal to come back, right? Yep. So you've tested basically all of the current modern long range control links: Ghost, Crossfire, Express LRS, Tracer, DJI. Do you test DJI control or just video? Just video. Just video, not control. Yeah.
I mean, presumably DJI control gets out to the limit of video, so it's actually not that interesting. Any others you've tested that I'm leaving out?
No, that's pretty much it. I've done both 900 and 2.4 of Express LRS. But yeah, you pretty much nailed it with your list there.
Yeah, and I think a lot of people there's two schools of thought about this testing. Because on the one hand, if you fly long range and your question is what protocol will get me out to 40 kilometers, because that's just what I want to do, then you're very, very interested in these results. But I think we're so spoiled for choice today because any of these protocols will have more range and penetration than a typical 5 gigahertz video link. Would you agree with that statement?
Yeah, definitely. I mean, the 5.8 gig link is my limit at the moment. Like I said, I'm getting up to 40 kilometers, but I'm not fail-safing with those links. So I guess the point that you're probably getting at is that even if you're not interested in doing 40 kilometers of range, these results might still be useful to people because you can, even if you're doing, freestyle or something like that, you can kind of see the comparison. If Tracer's making it to 5 kilometers on 100 milliwatts, but Ghost and Express LRS are pushing out, 30, 40 kilometers and potentially still not fail-safing, you can again extrapolate those results back and say, okay, well, if I was doing freestyle and I had a bunch of stuff that I'm trying to penetrate through, which one's going to do better? And so I think it's more interesting for people, everyone, rather than people just doing long range.
Yeah, that's a common point that people misunderstand, and maybe you could speak to it. Because people say, okay, Wezley Varty's doing range testing, but what about penetration? And as an RF person, range and penetration are almost always the same thing. There are a few exceptions where a specific material is specifically absorptive at a specific frequency. But in general, if a link goes further in clear air, like you're doing, will it also go further through like a bando?
I'm far from an RF engineer, and so it's definitely smarter people out there than me that would probably answer that question better, but I'd say yes, they should be very close to the same. If you're going 40 kilometers with one versus 10 with another, you'd probably be able to get 4 times that same penetration in a freestyle environment, I'd imagine.
Yeah, and the other thing that I think people miss is that, let's say you have 15 dB of loss in clear air, which is just kilometers and kilometers, but that could just be 2 or maybe 3 concrete walls in a bando. So the ability to go 50 kilometers in clear air could translate to, 2 or 3 additional walls at a bando, even though that's only maybe 50 more meters in space, which is so I really think the testing that you're doing, people should be paying attention to it, even if they don't fly long range, and they shouldn't just write it off as, oh, isn't it nice that he's pushing the limits, but it doesn't really apply to my daily life. It totally does.
Yeah, 100%. And I get a lot of questions kind of saying, why are you testing on 250 hertz packet rate when you would use the lowest packet rate possible for long range?
Right.
Testing on 250 gives you that good baseline where you'd say, okay, you can bring that back to any application. 250 is it's becoming, in my opinion, the standard rate. Like, 500 is what you want to use if you're bleeding edge racing, going as fast as you can. And 50 hertz is what you want to use if you're actually doing proper long range. But 250 is that nice middle ground where you've got good control latency, if your packets are coming in fast enough, but you're not compromising RF performance by going as fast as you possibly can at the expense of range. So that's kind of why I've chosen that as the packet rate for my testing, is because you can directly compare that to what you'd be running for freestyle or racing or a lot of things.
Yeah, the other thing is that you kind of have to do things to reduce the range of the link. I don't mean like unfairly, but like I'm surprised you're testing at 100 milliwatts and not like 10 milliwatts. Because if you were to set these protocols at max power and 50 hertz minimum rate, you would never be able to make them fail safe. They would just all go out to the edge of your range and you wouldn't learn anything.
Yep, 100%.
Well, maybe not all of them, but a lot of them.
Yeah, good point. That was kind of one of the things that I mentioned when I tested Crossfire, is like, people kept saying, oh, test Crossfire on 1 watt or test Crossfire on 2 watts. And I'm like, I don't have a 600 kilometer plane. Like, it's never going to happen.
Yeah. So. And as you pointed out, it's a characteristic of RF that just definitively, if you can go this far on 100 milliwatts, and then you can just calculate a multiplier for how far you could go at any other output power. And generally that result will hold true. So there's no reason to go to test at 1 watt, especially because not everybody goes to 1 watt. So the links that you've tested, who goes the farthest?
From my testing to date, Express LRS is the one that I'm still pushing the limits on, and I just can't get it to fail safe. So that's that. Like you said before, that the only way I can get this to fail safe is to use a tiny SMD antenna, or 10 milliwatts. Even on 10 milliwatts with 900 megahertz Express LRS, I still couldn't get it to fail safe, and that's the lowest power setting that you can select.
Yeah. So you're at the lowest power. You're at 250 hertz packet rate. It's 900 megahertz frequency, so you are getting a little extra penetration there, but 10 milliwatts is not that much power. How far out did you take that?
That was the 40 kilometer one.
Respectable.
So 40 kilometers on 10 milliwatts, which that kind of surprised me, even on 900 megahertz. Like that's tiny amounts of power, and it still wouldn't fail safe at 40 kilometers. So
now, to be fair, we have to ask, did Crossfire, surely you tested Crossfire 900 megahertz under the same conditions. How far did it go?
That one didn't fail safe either. So it's inconclusive between those two.
Gotcha.
I kind of, in my results, the comparison that I made was to RSSI dBm. So the signal strength received on the receiving end. And Express LRS had a slight advantage there. And based on that, you could kind of say, okay, well, this will go a lot further than what it currently is at 40, but Crossfire's only got a little bit left in it. So that was kind of the only...
You felt like Crossfire, based on the RSSI dBm, was kind of close to the edge of range, whereas you felt like Express LRS had more in the tank. But you didn't fail safe either of them.
Correct. And RSSI dBm is a really useful metric, because what you can do is you can test this yourself, where you basically just plug in a quad, set everything to the lowest settings, and put walls and everything like that between you, and basically get it to the point where it's on the edge of fail safing. And the RSSI dBm that you've got there is the sensitivity.
Right.
And so you measure the sensitivity on Crossfire, and then you say, okay, well, out at 40 kilometers, it was 3 dB away from its minimum sensitivity, and then you can work out how far it would have gone.
Right. Express LRS does make some compromises, though, in order to get that. And I feel like it wouldn't be fair to not just say Express LRS just goes the furthest, no compromises. Can we talk a little bit about what you give up in Express LRS to get that performance, that range?
Yeah, absolutely. So one of the things that Express LRS does is we send 4 full resolution control channels for your sticks, and then the rest of the channels are lower resolution. And I say lower resolution because it's kind of almost changing every day with some of the guys that are making changes. Captain Bry has a pull request coming that extends it up to something like 64 switch positions on each of the aux channels. But at the moment, it's 3 position aux channels with 1 16 position channel. So if you're trying to do something like a head tracker or servo control on a plane or something like that, that's not really going to work very nicely. You're going to get this really jagged movement with the low resolution. So that's one of the things that we do to try and get the range. There were a lot of compromises, like we didn't have telemetry originally. Yeah. So that was one of the compromises that we had. But all of these things were really pushing to add, telemetry was added, MSP was added, which is something that Crossfire's had for a long time. So you can use your Betaflight scripts and things like that. Some of the 2.0 is going to be amazing for Express LRS. There's some really cool features coming. We've got, the VTX control that you get with Ghost and TBS, where you can set your VTX from your Lua script. And things like that. So we're slowly building in all of these things and kind of building out that suite.
That's one of the things that has excited me about the Express LRS project. I'm not trying to turn this interview into an Express LRS love fest, but it is such a fast-moving project, and it's almost hard to find things to complain about, because every time I complain about it, 2 weeks later, they've fixed it and they've upgraded it. And so today we're doing this interview, and Express LRS has 1 16 position aux channel, and then most of the aux channels are either 1 position or 2 position or 3 position, I think. And 2 months from now, it's going to be nah, we have full resolution aux. I don't know. And it feels like it started with, there are all these trade-offs we've made to no telemetry except for VBAT, no MSP. But we have this super fast performance, and somehow you keep sort of squeezing more out of it without giving up the performance. It's a little if I were TBS, I'd be looking over there going, and a little worried, not to try to start trouble, but
that could turn into an interesting conversation. But I have watched a few of the live streams from Trappy lately, and there's a lot of questions about ExpressLRS. Let's leave it at that.
Yeah. So at 900 megahertz, you tested ExpressLRS and Crossfire, right? You got some kind of range. But a lot of people these days are saying that 2.4 gigahertz is the future. And not 2.4 gigahertz like people think of FreeSky and Spectrum. No. This is LoRa, the Semtech chip that does this great range. Why? But still 900 megahertz has better range, all else being equal. Why are people saying 2.4 gigahertz is the future opposed to 900 megahertz?
Yeah, I guess like there's the obvious things. You've got smaller antennas, so mounting them on quads is easier. And then, you've also got things like the SMD antennas on ExpressLRS, which makes it even easier for racing and things like that. Faster packet rates. So with 900 megahertz, you're kind of limited to how fast you can go with squashing all that data in. And then there's the less obvious ones like it's an international band. So having a wider band, and especially that's really important for guys in the EU because they've got a tiny band on 868. So being able to use 2.4 there is a huge advantage. And, people, like you said in your question, people compare it to FreeSky or something like that, 2.4. It only goes, 1 or 2 kilometers or something like that. But obviously that's not the case with 2.4 LoRa.
Right.
And that was kind of one of the motivations for the test is like, I'm sure you saw it, but when Ghost came out, which was kind of exactly around that same time that ExpressLRS was bringing out our DIY 2.4 hardware, everyone was kind of jumping in comments and saying, this is never going to work, 2.4.
They didn't understand the power of the LoRa, the technology. It's not the frequency, it's what you do with it that matters. And LoRa does some pretty amazing stuff.
Yep. So that was kind of one of the motivations for testing was like, kind of proving that point and showing people, hey, this thing is worth flying. It is comparable to 900 megahertz. And if you're not kind of punching RF through mountains or, flying in dense forests, kilometers through trees or something like that, where you need your best penetration possible, then 2.4 is going to do the job 100%. And you get all these other cool advantages of, small antennas and faster packet rates and things like that.
Yeah. So what kind of range you've tested? We got Ghost is 2.4 gigahertz. A Tracer is 2.4 gigahertz, but doesn't use LoRa. It uses a modulation called FLRC, which has more bit rate, more throughput, but lower range. And then, of course, there's ExpressLRS 2.4 gig. Those are the big ones, I think. Are there any other 2.4 gig? It's like, I think FlySky has one, but nobody uses it.
Yeah, there was some smaller ones that didn't really take off. Like there was the CE one that's using the same Semtech chip. And there was also, there was the FlySky, the FM30, or I can't remember the name of it, but they had one too, which, they could have done well. I feel like what let them down was marketing. They just kind of built this awesome module and said, hey, here's this awesome 2.4 gig LoRa link, and then just released it and said nothing about it. And nobody really...
I thought about reviewing it. I had the opportunity to review it, and I didn't. And one of the reasons was that releasing a technology, releasing a product is all well and good, but you need after-sales support. You need firmware updates. You need bug fixes. And it just, especially after the FlySky Nirvana debacle, where the product was released and then kind of abandoned. I know it wasn't totally abandoned. People always correct me on that, but I just didn't feel confident steering people towards FlySky because I wouldn't feel confident that they would continue to support the project. Of course, then it became self-fulfilling prophecy, So of those, Ghost, Tracer, and ExpressLRS, what kind of range test results did you get?
The ExpressLRS 2.4 gig link, unknown at the moment. So I've been out to 35 kilometers on 2.4 at 100 milliwatts. Ghost, I think, was around 29 kilometers or something like that. Did fail safe on the maximum power output. I think it was similar when I retested on 100 milliwatts. So around that 30 kilometer mark for Ghost, which is pretty impressive as well. I was impressed with Ghost. It's comparable for sure. Tracer, on the other hand, was like 5 kilometers on 100 milliwatts. And I suspect that it's that RF noise that's causing that. That's kind of around that point where in the flight path. So it would probably go further in a lower noise environment. But that, I think, is the weakness with Tracer is, like you said, it's using FLRC, which is more susceptible to noise. And TBS, it's true that FLRC is better for more data throughput, but the sensitivity values for FLRC actually get better if you go faster. So above 500 hertz, FLRC is actually better than LoRa. But below 500 hertz, LoRa just smashes it in terms of
that's pretty
sensitivity
weird.
Performance.
That's counterintuitive for sure. So why isn't, I mean, you can't read minds, but why wouldn't you just run Tracer at 500 hertz or 1000 hertz?
Yeah, I'd suspect that the reason that they can't do that is similar to the reason why they're struggling to implement LoRa with Tracer, which is TBS obviously use some really fat packets because they have all of those extra features. They have Mavlink. They've got a ton of, MSP type features that rely on that. They've got full resolution channels and, up to 12 or 16 channels or something like that. So they're putting all of that data over the air all the time and trying to squash all of that into a smaller packet, which you need to go faster and faster, just isn't possible for them. So I suspect that they're doing something like breaking up packets and then recombining them at the other end or something like that.
Interesting.
So I think that's their limitation. That's their kryptonite at the moment, is having too fat packets to push down over the air at really fast rates.
Well, it is a fact that they have, I mean, I don't remember the exact number, but it is true that they carry a lot of data in their data packets, and it allows them to be very full featured. Arguably, a lot of these features are a little bit niche, like the MSP, not the MSP, the Mavlink stuff. Long range people obviously are using the hell out of it, but what percentage of users are they? But when you've got to carry more data and you only have a pipe that's so big, you can only push data through it so fast. So it seems like if they were to switch on LoRa in Tracer, they would be down at, I don't know what the number would be, but it would be a 50 or 100 hertz or lower packet rate, which then would look bad compared to the competitors.
And then it competes with Crossfire as well.
Well, sure. Yeah. And I think they don't want to do that. But it is interesting. It will be, I mean, I'm sure they're aware of it, and I'm sure they're working on it. And who knows what kind of tricks they might have up their sleeve to, split things, but, carry the 4 main control channels in every packet, but split the telemetry into every, I mean, that's what ExpressLRS does with the telemetry, right? You don't carry telemetry in every packet.
Well, we carry some part of it. So telemetry is actually one where we're doing something similar to what I just explained, where we split it on the sending side and then recombine it on the receiving side. So we just have a data rate, a throughput rate for telemetry, and we just push bytes through at that rate. And then, when you've got enough bytes to recombine your GPS packet or something like that, then it gets displayed on your handset.
Interesting. Very interesting. So you're sort of just scaling up how much payload you put in each packet based on how much free space, just kind of stuffing it in the free space. And then when it all gets there, and maybe it takes longer to get there, but telemetry sensors don't need like super fast updates anyway.
Exactly. And we let you actually choose that rate. So when you go into telemetry ratio in your Lua script, you can see how many bits per second you're sending when you select 1/8 or 1/16, etc.
Yeah. I have hassled, and I've said this publicly, so I'm not speaking out of turn. I've hassled TBS about not unlocking LoRa support in Tracer. I've said you should give your customers a choice, right? They should, if they want to go slower but have more range, why would you not let them do that? And I feel like now the difference between TBS and the ExpressLRS devs is that you guys work for free on your spare time. So, you just do or not do whatever you want. But is there potential plans to have FLRC support in ExpressLRS? Do you know of anything like that? So people can go even faster if they want to.
Yep. There's been a little bit of testing, kind of proof of concept work. and it doesn't look terrible, but you can definitely see the compromises. And kind of, like you said, everyone's kind of doing it on their free time. So, somebody does a little bit of a proof of concept, and if somebody doesn't have the motivation to kind of make that productized and get it into a user-friendly format and everything like that, then it just doesn't happen. But there's definitely been some experiments, and it doesn't look terrible. But at the moment, kind of we're getting good performance out of LoRa anyway. So unless you are pushing to 1,000 hertz or 750 hertz or something like that, why use it? And until EdgeTX and OpenTX and things like that can support getting the data out to Express LRS that fast, then there's no point to jump to FLRC yet.
Yeah, good point. TBS has these big fat packets. So in order to get 250 hertz, they had to make the switch to FLRC. But if you can get 250 hertz on LoRa, then why accept the reduction in range just to not go any faster? Yeah, good point. Before we're coming to the end of the hour. Before we wrap up, I want to talk to you about hardware design for Express LRS. Express LRS started with people literally soldering up their own modules and receivers from reference designs. And as was inevitable, now there are commercial implementations. Happy Model makes hardware, Beta FPV, HGLRC, JHEMCU, and Naminmo are some that come to mind. What do you think? My first thought was, well, Happy Model, Beta FPV, these are not necessary. Do I want my controller module to have the same build quality as a Beta FPV 95X? What have you seen, as this hardware has gotten out there, and what are your thoughts about that?
What really helps is if the manufacturer come to us and talk to us first. And we kind of ask that they show us their designs, their schematics, their PCB layouts and things like that. So we basically just put together a Discord chat and just say, no, you're doing it wrong. Just use the reference design, stop using that silly filter, or, you can't put ground underneath the UFL or something like that. So we've tried to kind of make sure they're doing it right before it gets into consumers' hands. But you can only tell people something so many times and then have them not listen and release crap anyway, which is, something that some of them have done. Happy Model, they were the first ones to come on board. So I think we owe them a lot of credit for kind of taking something that wasn't really proven yet, and taking a gamble with building Express LRS hardware and manufacturing it and everything like that. The investment there was fantastic. And I think they've done pretty well. They've had a couple of issues. They've had the Slim Pro issue, and they've had the regulators on the RXs and things like that. But we've heard the kind of numbers of units that they've pushed out. And when you hear about the number of failures that they've had, it's pretty low in terms of percentage for manufacturing failure. We haven't had a lot of people jumping on Discord saying, hey, I got some spare capacitors in my bag that weren't attached to the PCB.
Right.
Which other bigger companies do have problems with. So
shots fired.
Yeah.
I think what you're saying is that no one is immune. No one is immune to hardware failures and manufacturing defects, not even the biggest of the big.
Exactly. And, we've had some some companies that may not have the best reputation come on board at the start, but we've also got some other guys that definitely do have good reputation, kind of teasing hardware that they're in development with at the moment. So, watch this space, I guess. There's some big players kind of jumping on board.
Well, I'm excited about it because, we're seeing more and more bind and flies being available with Express LRS receivers, which I think is a good sign for the future of the project. And I think the success of Express LRS is a success for the FPV and the RC community as a whole. I think whenever you've got a team out there who is doing exciting things and pushing the limits, let's flip it the other way. When you've got one entrenched player who everybody uses, they have little incentive to really push themselves to innovate. They're going to innovate incrementally and try not to upset the apple cart too much. But as soon as you get somebody out there who's just doing radical things, everybody looks over and goes, whoa, that's cool. And then everybody has to kind of play catch up. And I think it's exciting that ExpressLRS is doing that. And it's also, as you said, exciting that companies like Happy Model and Beta FPV and so on are putting the money into making these products, because it does contribute to the success of the project as a whole.
Yeah, one of the things that blows me away is like, we've got people that you'd have to be paying $100K a year as a software developer, like as a firmware developer, if they were employed by TBS or Immersion RC or something like that. And these guys are getting in there and putting hours and hours every day into building something for free. And that's just that enthusiasm and, you know, the love for the hobby and everything like that that's driving them to make something better. And I guess also like the opportunity to kind of change the way your control link works, to get in there. It's open source. Anyone can submit a pull request.
Yeah.
So,
or fork it and make any of the changes you want and flash it yourself.
100%. So I think, having that as their motivation has really pulled in some really, really smart guys, which you'd be paying big money to get that kind of skills at somewhere that was closed source.
Well, that that has been a criticism of the project. I wonder if you want to respond to that, because there was a statement that was basically like, these guys are undercutting Ghost and Crossfire because they're doing the R&D for free, and then a Happy Model comes along and they just solder up some receivers and they don't have to pay for the R&D. And I think it was levied as a criticism. I don't know. You have any thoughts about that?
That was an interesting argument, that one. I mean, you could make the same argument for Betaflight versus Flight 1 or something like that. Those guys, Betaflight, it's all open source and people contributing their own time and effort and everything like that. And, those guys aren't getting up in arms about iFlight making an FC and using Betaflight or something like that and going, where's all my royalties? So it's not something that we expect. Like, we're not trying to make bank out of our firmware or anything like that. We're just trying to build something awesome. And, why wouldn't you let everyone else appreciate that? And, we really, really appreciated having the manufacturers come on board, to be honest, because like you said, before that, you had to solder up your own hardware. So making it accessible by providing hardware was a huge step forward. So we were kind of praising them, saying, great. It's amazing to have you guys on board, happily make as much money as you want off it.
Right. Yeah. More power to you. So, and frankly, people can still solder up their own if they want, or there's people out there, like Fatboy FPV comes to mind as a website. He solders them up and he'll sell them for you. So if you decide that you want one that's been lovingly hand soldered, then you can still get it. It's still out there. But if you want one that's been made on an assembly line and costs you $13, you can get that too. I'll put some links down in the video description for people who are interested in learning more about ExpressLRS and or getting into it. But I think that's going to just about wrap us up. Wezley, your YouTube channel is going to be linked in the video description as well. You have some tutorials and do you do product reviews?
I've had a couple of reviews on, chargers and things like that. Most of my product reviews are all on the RC links. That's kind of
and a lot of range testing. A lot of range testing. I want to compliment you. It's very challenging to present technical information in a way that is accurate and engaging and entertaining. Your presentation is really good. I really enjoy watching your videos, and just your production and your video production is also really good. So definitely people should check out your channel.
Yeah, thanks. And I really appreciate the support. Thanks for having me on, and great talking to you.
Awesome. All right, man. That's going to do it.
Cool.
All right. I was going to say have a good night, but it's morning where you are. You're about to go to work, and I'm about to go have dinner. So
it's 9 o'clock here. Yep.
Isn't that amazing? All right, man.
Yep.
Talk to you later.
Great.
Bye-bye.
Cool. See ya.
What are you doing? Hey there, it's me. End of the episode, Joshua. I'm just out here taking a walk with my dog. If this is the first time we've met, nice to see you. And if this is the second, third, fourth, 17th time we've met, you sure seem to like my content. So I hope you're subscribed. And maybe you could think about joining my Patreon, where you can support me for a couple $1 a month and help buy dog food for Mamba here. He's not named after a flight controller. He had that name when we got him, but it sure is a nice coincidence. Here's some videos I thought you might like. Anything to say to the people, Mamba?